Hello, this is my walkthrough for my calendar application project. This video shows the completed system features, explains the design patterns implemented throughout the application, shows the unit test running in Qt Creator, and a brief reflection on the development process. The overall architecture of the system is organized around a clear separation of responsibilities between the domain logic, user interface, and the data layer. At the core of the application is the schedule manager class, which is responsible for storing and managing all schedule items, including tasks and events. The schedule manager is implemented as a singleton to ensure that only one instance exists and that all parts of the application operate on the same shared schedule data. The UI controller acts as the mediator between the user interface and the domain logic, coordinating user actions such as creating items, navigating between views, saving and loading data, and sending notifications. The graphical user interface is composed of three main views: day view, month view, and year view, each responsible solely for displaying information and handling user input for a specific timescale. Additional supporting classes include the item creator class for centralized object creation and the save and load class for persistence data persistence using JSON files, and the notification manager class for time-based reminders. When the application is launched here, yeah, when the application is launched, it opens in the year view, allowing the user to select a specific month. Months that are highlighted blue like this are months that already have schedule items made in them, and same with days here. Selecting a month transitions the user to the month view here, where individual days can be chosen. When selecting a day like here, like opens the day view, which displays all tasks and events scheduled for that date. Tasks are shown as tasks are shown as centered time blocks around their due time and are colored blue here, while events span their defined start and end times and are colored green. Users can add a new add a new schedule items directly from the day view using the add item button, which allows them to choose between creating a task or event and to enter the relevant details. So like this, uh, just like a test at a random time, you can just say that, and you can make a schedule item like that. Items can also be deleted from the day view by clicking on them like this, and then pressing the delete button up here at the top, and it's gone now. And there's also a back button here to at the top, which can be used to go back to the month view from the day view, as well as go back to the year view from the month view. The user interface automatically updates to reflect any changes. Navigation between the views is handled through the UI controller, ensuring that the views remain decoupled from the application logic. Several design patterns were applied to improve maintainability and extensibility. The singleton pattern was used in the schedule manager to provide centralized control over scheduled data and to maintain consistency across multiple views. The observer pattern was implemented between the schedule manager and the calendar views, allowing views to register as observers and be automatically notified when scheduled data changes. This ensures that all views remain synchronized without tight coupling, and the factory pattern was implemented through the item creator class, which encapsulates the creation of task and event objects and removes object construction logic from the UI controller. Together, these patterns improve modularity, reduce dependencies, and make the system easier to extend. The application also includes automatic saving and loading functionality implemented through the save and load class. All tasks and events are automatically saved to a JSON file, and the data is reloaded when the application the data is automatically reloaded when the application starts without requiring user interaction. The notification manager runs in the background. The notification manager runs in the background and periodically checks for tasks and events that are due or approaching their due times based on configurable lead time. When a qualifying item is found, the notification manager emits a signal that results in an on-screen reminder being displayed that I'll show you here now. Like this. Okay, and now onto unit testing. These are the two unit testing classes. Unit testing was conducted using Google Test and Google Mock to validate the behavior of two classes, the schedule manager and the notification manager. The schedule manager tests verify that items can be added and deleted correctly, and that observers are notified when changes occur, and that due items are returned accurately based on time. The notification manager tests verify that notifications are emitted for due items, that lead time logic is respected, that duplicate notifications are prevented, and that multiple due items are handled correctly. Google Mock was used to mock observers and receivers, and expect call statements were used to validate interactions and signal emissions. All tests passed successfully, as you can see here. All 14 tests, 8 from Schedule Manager and 6 for Notification Manager. One of the main challenges encountered during development was managing shared state. The shared state due to the use of the singleton pattern in Schedule Manager. While the singleton simplified data access and ensured consistency, it also complicated unit testing at first because the state persisted between test cases. This issue was easily resolved by just switching to Google Test fixtures to reset the singleton state before each test, something I decided not to implement in the final deliverable here is the implementation of the editing of being able to edit existing schedule items and repeating the schedule items, as doing so would have required more UI complexity, and instead I chose to focus on ensuring the reliable creation and deletion and persistence between views. Overall, the project reinforced the importance of clean architecture and the thoughtful use of design patterns and writing testable code.